This one. Just 1 minute. Okay. Is it visible? I think. Now the experiment is this one, series voltage injection. Okay, this is the experiment. Study of power transfer control using series voltage injection. Okay, so in the laboratory, basically we shall have a setup. That setup, since you cannot have the transmission line in the laboratory, we shall have to develop the model of transmission line, and the model of transmission line is basically a reactor. So transmission line, if you consider a short transmission line, it basically consists of resistance and inductance. Okay, so if you use an inductor, that will sufficiently represent the transmission line. So what we have done in the laboratory, we have used an inductor or reactor. Since the reactor will consist of resistance and inductance, it will represent the short transmission line. Okay. Now this transmission line is represented here between 1 and 3. You say see a section here between 1 and 3, as if this is representing the transmission line. Okay. Now we have a power supply source here, and is another power supply here, because in power system you know that system is interconnected. So you have interconnected power system. In interconnected power system you will be so many sources connected together. So on the both sides of the transmission line you may have sources. Rarely will have transmission line where source is connected at one side only. Actually, source is connected at one side of the transmission line if the line is of low voltage. Okay, basically low voltage lines are connected to the power system or power station or substation, and the other end is connected to the load end. Here, in interconnected part of the power system, basically the high voltage part of the power system constitute a grid and network, and that grid network had so many sources. So we can say that sources will be present on both sides. That's why a source is shown here, another source is shown here. So here on this side you have both a variac, three-phase variac, along with a phase shifter. Three-phase variac will be there to control the voltage. Here the single phase variac is there because we are actually dealing with only one phase. Only one phase will be actually considered here, but three-phase variac is required at this end because we shall be using phase shifter at this end. So for phase shifting, you will record all the three phases, because how will affect the phase shift? Basically, say A phase voltage in series with that you connect a part of the B phase voltage. So basically there is a phase angle difference of 120-degree between A phase voltage and B phase voltage. So A phase voltage, you assume that voltage is of 100 volt. So if you connect say 20 volt of B phase with A phase, then effectively there will be a phasor representing the combination of 100% of A phase voltage and 20% of B phase voltage, and at the same time there will be a phase shift. So this is how phase shifting is actually implemented in this phase shifter. Could you get the point? That means one phase voltage is added with the other phase voltage, and how much will be the phase shift, what will be the magnitude of voltage, effective voltage finally, that will depend upon the combination of two voltages. So as a result you will have a control of the voltage magnitude as well as control on the phase shift. Okay, so that's why a three phase variac and three phase phase shifter is needed here. Okay, there is another phase shifter. Why this another phase shifter is required, I am explaining. This another phase shifter, and this phase shifter is actually someone has joined. Let me see. Hmm. Which part I was discussing? Acha. Okay. Then uh, you see that there is another phase shifter. Okay. This phase shifter is connected with the transformer. This is a 1:1 ratio transformer. This transformer is used to inject the voltage. Our experiment is on series voltage injection. That means with the transmission line is connected at this end and this end is connected at this end. Okay, so is already a voltage at which the transmission line is charged. So along with this, in series with this line, we are connecting one winding of the transformer. So that means this transformer is connected in series with this transmission line. And what we can do, we can connect a voltage, add a voltage with the line voltage with the help of this transformer. How much voltage we can add, at what phase we can add, that will be controlled by the help of this phase shifter. Okay. So there are two phase shifter. One is here. This will be used to inject a voltage in series with this line. Okay. And this voltage will be used, this phase shifter will be used to control the phase angle difference between this end voltage and this end voltage. Is the purpose clear to you? That means two phase shifter. Say this transmission line is connected between end 1 and 2. Between end 1 and 2, we need a phase angle shift, and that shift is implemented by this phase shifter. Okay, and we are connecting a series voltage with the transmission line. How this voltage is in connected in series voltage injection, how this voltage is injected in series with the transmission line voltage, that is by means of a 1:1 ratio transformer. This is 1:1 ratio transformer between this 4 and 5. Okay, so the purpose of this phase shifter is to control this voltage. That means how much voltage we shall add, at what angle we shall add. That means the angle will be controlled by this phase shifter too. Also the voltage magnitude, because it is again connected with another variac here. This is represented by that variac. This is representing that variac. This is the phase shifter. So that voltage as well as phase will be adjusted by this phase shifter. Okay. Why? What is the purpose of this experiment? Actually, nowadays uh, you have three-phase power transmission. Most of the transmission voltages are basically in three-phase, and there are as well uh, HVDC transmission. HVDC transmission has so many advantages over AC transmission. At the same time, AC transmission is having many advantages over the DC transmission. So people wanted to retain the advantages of AC transmission. Along with that, they wanted to have some of the good features of the DC transmission, and that can be achieved by means of flexible AC transmissions devices, or called the fax devices. These fax devices basically are power electronic devices. Okay, and one of the fax devices is the UPFC, Universal Power Flow Controller. UPFC means Universal Power Flow Controller. What this Universal Power Flow Controller can do, it can control the power flow through a transmission line. At the same time, it can control the voltage at one end. That means both voltage and active power flow may be controlled with the help of UPFC. At the same time, okay, so UPFC is a fax device. This fax device can actually control the active power flow, how much power will flow through a transmission line, magnitude of this power, active power, and what will be the terminal voltage of that line. These two things may be controlled with the help of UPFC. That will be implemented through power electronics. Here, we are not using power electronics to control the voltage and phase angle. Rather, we are showing that effect. That means what the UPFC can do. That had been demonstrated, that is being demonstrated here with the help of this series injection. Basically, the basic principle that the UPFC follows is this series voltage injection with the transmission line. UPFC basically add series voltage with the transmission line voltage so that terminal voltage and active power flow is controlled. Here also, using these analog devices, we are actually injecting voltage in series with the transmission line, and that voltage is being added at a certain at different phase angle, and effectively we are getting the control of active power flow and control of voltage. Okay, so what UPFC is doing, that is being implemented with the help of this arrangement. Okay, this is our main purpose. There is another purpose. So what is that? Another fax device is called interline power flow controller that can actually control that or transfer the power between one line to another. That means, assume that there are two parallel lines, double circuit line. You know, you heard about double circuit lines. In double circuit lines are adjacent to each other. In most of the cases, they run on the same tower. Okay, double circuit line. So using the fax devices, basically the interline power flow controller, okay, IPFC, interline power flow controller, we can actually transmit power from or transfer power from one line to another, and that as if is demonstrated here again with the help of this transformer. Actually, in that case, in the second part of the experiment, I shall also mention then as if this is the first line, and this then representing the second line. Here we have not elaborated this line in the second case. Okay, in the third run of the experiment, you will see that this is happening. We shall show that power is being transmitted or power is being transferred from this line to this line. Here, basically, this line is represented with the help of this winding of the transformer. So, with the help of this experiment, our intention to demonstrate, or our intention is to understand the basic principle of operation of UPFC and IPFC. UPFC means Universal Power Flow Controller, with the help of which we can control the active power and voltage of a transmission line. Obviously, we can control the voltage at one end, and in effect, voltage of the other end also will be somewhat regulated. Okay, and the second is the IPFC, interline power flow controller. Here we shall be transmitting power, or we shall be transferring power from one line to another. Magnitude of IPFC advantage is, say you have two transmission lines. Okay, say obviously the starting or the generating, what you can say, sending end of both the transmission line may be at the same location, but maybe the receiving end is reaching at different location. Okay, so what we can do, we can transfer a part of power from second line to first line. Okay, while the lines are in the running, then a power of from second line is being transmitted to the first line. This type of transmission, or this type of transfer of power from one line to another, these are very effective when you are controlling the operation of power system. Maybe you are controlling the operation of power system, you have to control the stability of the system. In that case, sometimes it may become very advantageous if you can transmit a part of power from one line to another. In those cases, that means basically for controlling the operation of power system, this IPFC will be very useful. Okay, that is being demonstrated here. Okay, say do two transmission line. Okay, so their impedances are same. So if you operate this line from the same bus, then what will happen? Power will be basically shared equally between divided equally between these two lines, but you want that more power will be transferred through line 1, and a smaller part of the power will go through line 2. So then you can, what you can do, you can use this type of features, IPFC or UPFC, to control the magnitude of power through transmission line. Okay. All right, so why this experiment, what is the purpose of this experiment, what we are going to demonstrate here, that I have discussed. The basic principle of this power flow control is, maybe it was not discussed previously, but basically, so that is the what we can do, in phase voltage boost and quadrature voltage boost. These are the two things. That means what you can do, you can actually add voltage in phase with another voltage, and that will increase the magnitude of voltage at one end. Okay, by this you can control the voltage, in phase voltage boost. And quadrature voltage boost means when you add voltage at 90 degree with the existing voltage. So what you are doing, you are adding a voltage at 90 degree with another voltage. So that is called the quadrature voltage boost, and that basically controls the phase angle difference between the two voltages. When you add voltage in phase with another voltage, then the voltage magnitude basically increases. By using in phase voltage boost, what will be happening, since the voltage magnitude will increase, okay, there will be control of reactive power flow. Because you know that from third year, perhaps third year B section, power system performance, obviously it was discussed in your section also, that active power flow may be controlled by controlling the phase angle difference. Or for the control of active power, basically the phase angle difference has to be controlled. And for the control of reactive power, voltage magnitude has to be controlled. Or reversely, if we say that if we control the voltage magnitude, we shall be controlling the reactive power flow. If we control the phase angle, we shall be able to control the active power flow. Okay. So in phase voltage boost controls the reactive power flow. Quadrature voltage boost controls the active power flow. Here, through this arrangement and through that what we were discussing, that UPFC, IPFC, they are basically using this concept, okay, using power electronic devices. We are implementing this using this transformer, okay, along with the phase shifter. All right. Now, what are the equipment necessary in the transmission line? In the laboratory, you have transmission line that is represented by a reactor. That reactor is shown here between 1 and 3. Series voltage source represent, this is the series voltage source, 1 is to 1 ratio transformer between 4 and 5. Okay, single phase variac is here. Basically we shall be doing this experiment using only one phase of the transmission line. That's why we have a power supply source here using a single phase variac. We have also three phase variac and phase shifter 1. Three phase variac and phase shifter 1. Why three phase variac is needed? Because phase shift team requires all the three phases. Otherwise, you can implement phase shift. Okay. So since you are using all the three phases, variac also has to be three phase. So combination of three phase variac and three phase shifter, that is needed for control of phase angle difference of this voltage with respect to this end voltage. So this is the transmission line. We are controlling the phase angle difference between these two ends, and that is by means of this phase shifter. And for the operation of this phase shifter, because when you shift the phase, along with you have to control the voltage magnitude only, that's why variac is necessary here. Then three phase variac 2, it is needed here along with the phase shifter 2. Why this is needed? Because it is acting as the source for the series voltage, for the voltage injection, and voltage injection is implemented with the help of a 1:1 ratio transformer. We shall be controlling the magnitude of voltage and phase of this voltage by the combination of three phase variac and phase shifter. Okay. Now you require so many meters, because in this experiment so many measurements are needed. Voltage is to be measured by using say 4 5 locations. Okay, at all the locations you'll be measuring the voltage, 1 2 3 4 5, all these things. How much is the voltage here, how much is the voltage here, what is the voltage here, what is this voltage, what is this voltage with respect to ground, or what with respect to neutral. All these voltage will be measured. That's why the 5 uh, voltmeter. And emitters are also needed for measurement of current through the line. You'll be measuring how much is the line current. And also another emitter measure the primary current of series transformer, how much is the current flowing here. That will be measured with the help of this emitter. An emitter will be connected here, another emitter will be connected here. Okay. Now what meter also needed, because we shall be measuring power, we shall be controlling the power flow. So we shall have to measure the power. We shall have to measure the power at how much power is either entering here or leaving this location at 1. how much power is either uh, entering this point or leaving this point, how much power is either entering this point or leaving this point, and how much power is entering through this winding, or how much power is entering or leaving through this winding. So one, two, three, four, four powers are to be measured at this line, and one power has to be measured here. Okay, so there are two voltmeters. Sorry, there are wattmeters. Wattmeter one measures the active power at node 1, 2, 3 of line P1, P2, P3. This will be measured with the same wattmeter 1, 2, and 3, because the common point is here. So potential current, same current will be flowing through the line. So current coil will be connected in series with the line, and potential coil will be connected between this end and this end to measure this power, between this end and this end, and to measure this power at this location, and to measure this power. One end of the voltage coil will be connected here, another end will be connected here. So these three powers are measured with the help of a single wattmeter. That is wattmeter number 1 here. Okay. Then wattmeter 2 measures the active power at the primary of the series injection transformer P4. How much power is actually being injected by this transformer to this line. Okay. That means this power P4 will be measured with the help of one wattmeter, and how much power is either being delivered from this terminal, from this winding to this winding, or being received by this winding from this winding. This is measured by another wattmeter, that is wattmeter number 3 here. It is assigned number 3. Measures the active power at the secondary of the series injection transformer. So we are actually naming this winding and the primary winding, this winding and the secondary. You will see that for run 1 and run 2, this will be acting as the primary, and this will be between 2 and 3. That means this 5. This will be secondary winding. For run 3, this basically will be working as primary, and this will be working as a secondary, because power then will be actually flowing in the reverse direction from 5 to 4. Okay, so these are the instrumentation, different meters connected. This is the different components of the required for the performing the experiment. And now the procedure. Okay, now you have to measure the phase angle difference. Phase angle difference is measurement is very important here, because we have to understand in which direction power is flowing. And how to understand this? Because already we know that we studied that active power flows from, if you want to transmit power from one end to another, you have to maintain a phase angle difference. And in which direction active power will flow? Can anybody tell me in which direction active power will flow? In any run, in which direction active power will actually flow? Actually, oh, I actually forgot to do one thing. I did not start recording. So one thing, let me do. Let me start recording. I have not done it. How to start it is, where are the icons? This one. This one. Acha. Recording. Acha. Okay, okay. Because it's maybe needed. Yep. Start recording. Yes. Okay, okay. All right. Okay. That is gone. Okay. This was doing. Yes. Now, no. Say I want to transfer power from end one to end two. So what will be a phase relation between end one and end two for the transfer of power from one to two? Which voltage will lead and which voltage will lag? Which voltage has to lead and which voltage has to lag if we want to transfer power from, say, this end, this power supply end to phase shifter end. Okay, which voltage has to lead and which voltage has to lag, or there is no such requirement. Power always flows from leading phasor to lagging phasor. Am I clear? Power flows from leading phasor to lagging phasor. That means if we want to have power flow, active power flow from power supply this end to this phase shifter end, then voltage, that means V1 must lead V2. Okay, if you want that power will flow or power should flow from phase shifter to power supply end, then V2 must lead V1, because active power always flows from leading phasor to lagging phasor. And regarding reactive power, what is the direction of reactive power flow? Anybody? What is the direction of reactive power flow? Anybody? Tell me, what is the direction of reactive power flow? Reactive power flows from higher voltage to lower voltage. Okay, that means reactive power always flows from higher voltage level to lower voltage level, higher voltage end to lower voltage end of transmission line. Active power flows from leading phasor to lagging phasor. It is always possible that from a lower voltage to higher voltage active power is flowing. That means if you maintain voltage here lower than this end voltage, then also active power will flow from here to here, provided this voltage is leading this voltage. Okay, but if this voltage is having smaller magnitude with respect to this voltage, then reactive power will flow from N2 to N1. It is possible that active power is flowing from, say, N1 to N2, but reactive power is flowing from 2 to 1. It is always possible. That means phase angle difference decides the active power flow, and active power flows from leading phasor to lagging phasor. But voltage magnitude difference decides the reactive power flow. Reactive power flows from higher voltage to lower voltage. Is it clear to you, everybody? It is clear? Okay. So these are the basic things actually, and these things are supposed to be known from the discussion of power system performance, the subject you have studied in the third year first semester. Okay, so you are supposed to know all these things because all these things were discussed second semester, last semester. Okay, all right. Now come to the procedure. Now, therefore, you see that phase angle difference measurement is very important here because we shall have to ascertain in which direction power is flowing and how much power is flowing. So we have to measure this. That's why you have to measure the phase angle difference between different points. Okay, say delta 1 2 angle is delta 1, delta representing the phase angle difference between end 1 and or point 1 and point 2. That means phase angle difference between this point and this. That means phase angle difference between this voltage and this voltage is measured by delta 1 2. And we have a phase angle meter. That phase angle meter is having a reference point and a input point. Okay, reference point acts as the reference for measurement. That means we are measuring the phase angle of input. That means one terminal will be connected at the input end, another terminal will be connected at the reference end. And input end voltage either lags or lead the reference end voltage. The reading that will implement how much by how much angle the input and voltage is either lagging or leading the reference voltage. There will be a lead, actually light glowing will be either lead or lag. That will, the light is there, it will glow and show whether it is leading or lagging. That means whether the input voltage is leading or lagging the reference voltage. So reference is the delta 1 2. We shall have to see where the reference is connected. If we connect 1 at the reference and 2 as the input, then 2 will be the voltage which is measured with respect to, whose angle is measured with respect to 1. So we shall see where the end 1 is connected, where the end 2 is connected. Okay. So at does the okay part so similarly delta 1 3 delta 3 2, that means these are the phase angle differences, and between 1 and 2, one will be connected as reference, 2 connected another connected as input. In this experiment, whenever the readings were taken, some end is connected at reference, some other end at the input. Okay. So the let us see what is given here as instructions. So adjust the variac at the two ends of the line to make V1 equal to V2. So we are actually first seeing how power will flow if the two end voltages are made same. So between two ends, voltages are made same. Okay. So if voltages are equal at the two end, how much will be the reactive power flow? There will not be any reactive power flow. Okay, but there will be active power flow only. That has been ensured by making V1 and V2 equal. And there is no line capacitance considered here, so it is not possible that there will be other path for reactive power flow, because there is no representation of line capacitance here, and we have made the two voltages equal, means there will not be any reactive power flow. That's why we are making V1 equal to V2. Adjust phase shifter 1 such that V2 leads V1. So in the first case, we shall make V2 leading V1. Okay, by a suitable angle. So that will be measured at delta 1 2. So maybe 1 is connected at the reference point, 2 as the input. So if the reading should be leading, and the angle value shown here will give how much, by how much angle n2 is leading n1. Okay. So adjust the variac at the two ends to make V1 equal to V2. Adjust phase shifter 1 such that V2 leads V1. So phase angle actually will be adjusted by this one. Between these two voltages, you have to adjust the phase angle difference, and that is done with the help of this phase shifter 1. Okay. So and then okay, adjust variac 2 and phase shifter 2 such that P4 greater than P5. What we are doing, we are actually now injecting a voltage with the help of this transformer to this line. Okay, and it is done in such a way that P4 is greater than P5. That means some power is flowing from the primary of this transformer to the secondary of this transformer. Actually, as we are injecting a voltage in series with the transmission line, okay, that voltage also transfers some power to the other line. So here P4 greater than P5 ensures that power will be transferred from this winding of the transformer to this winding of the transformer. From the very measurements we shall be making, this is also will be clear. Okay. So the purpose of this adjustment given here, adjust Variac 2 and phase shifter 2 such that P4 greater than P5. Okay, so somehow you make that condition, bring that condition such that this power becomes greater than this power. So if this power gives how much power is actually being pushed by this transformer to the other end, and a part of that power will be reached at the other end of the transformer, and another power will be lost. Where that power will go, obviously that is representing the loss. So this P4 reading of this wattmeter will give you the total power at the input of this transformer, and reading of this wattmeter here will give you the power reached at the secondary of the transformer. That means this transformer is adding a portion of power with the power being carried by the line. Okay, and the difference between these two power will be the loss in this transmission line, the loss in this transformer. Okay. Now this is run 1, and then run 2. Then I will go for the sheet where the values will be discussed. Okay. In the first run, therefore, what we shall be observing? We shall be observing that power is being transmitted from phase shifter end to power supply end, because B2 will be leading V1, phase shifter end to this end. Okay, we shall make P4 greater than P5 such that the series voltage here is adding a power with the line power, with the power being carried by the transmission line. That means a part of power will be pushed by this phase shifter through this line. Another power will be pushed by this transformer to this line. As a result, total power here will be the summation of power reached at in here 2 and 5. That means from 4 to 5 a power will be injected. That power will be added with this power received here. So P2 plus P5 will become equal to P3. This power P3 therefore will be equal to P2. That means power received from phase shifter and this P5 is the power received from this transformer through the series voltage injection transformer, and P5 and P2, this total power will be equal to P3. So this P3 will be therefore the power at the input of this transmission line. This transmission line is represented by a reactor. Reactor is having some resistance. So when current flows, power flows through this line, a power will be lost and the remaining will be available here at point 1. So at point 1, if we measure the power, we shall get how much power is ultimately reached here from this end and through the series voltage injection. So P1 is the power received at the power supply end, P2 is the power delivered as the phase shifter end, and P5 is the power received by the injection source from the primary winding, and total power P5 plus P2 will be equal to P3. P3 minus this loss will be equal to P1, and P1 is the power reached at the power supply end. This is run 1. And now run 2. Run 2 will be the reversal of power flow through the line. Now power will be transferred from power supply end to the other end, this end. Okay, now therefore, since now we want to transmit power from power supply end to phase shifter end, V1 must lead V2. So we shall have to again uh, adjust the variac and phase shifter 1 such that V1 leads V2. Okay, so you see the process here keeps V1 and V2 fixed as round 1. That means voltage will be same. Phase shifter 1, adjust phase shifter 1 such that V1 leads V2 by a suitable angle, such that power flows from power supply end to phase shifter end. Adjust the variac and phase shifter of the series injection transformer, that is P4 greater than P5. Again, here power will be delivered by this series source to the line. So here what will happen? Power will be flowing from end 1 to end 2. Direction is reversed, and this reversal of power is affected by the phase shifter again. Okay, phase shifter allowing the series voltage injection. So now this power minus the loss on the transmission will be the power reached here. Then P3 is the power reached at the end of the transmission line. P5 is the power received from the series source. So P5 plus P3 will be equal to P2 power reached at the phase shifter end. Okay, so this will be the run 2. And then run 3. Run 3. Here power transfer between two lines, as I have mentioned. Obviously you can say that here also you could consider, instead of considering these as a series injection source, you could consider the transmission line. Actually what we could do, we could actually for run 3 represent another line here, use the series voltage source here. Then we could show the transfer of power from this line to this line. Rather, assuming that this is representing the line, we are showing that the from N5, that is from this line, power is being transferred to this line. This will be implemented in run 3. So for doing this, what adjustment are to be made? In run 3, adjust the variac and phase shifter of the series injection transformer to make P5 greater than P4. Now the from the line n to the transformer n. That means from, you can say, line 1 to line 2 as if. Note down that this is the only requirement, and voltage you can maintain as before. Okay, so these are the things, these are the three rounds to be performed here. Now let us see a report and show that how much, what are the values obtained. Yeah. Yes, sir. Yes. Hmm. 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 Just one minute. Huh? We are adjusting the phase shift also actually, but at the same time, what we do, since we are adding voltage introduce some other voltage, so you will see that in between voltages will be changed. In between voltages will be changed, but between the terminal, we are maintaining the same voltage. That means from this end to this end, there will not be any reactive power flow. In between, their voltage will increase, voltage will decrease, but that is happening here. Okay, but between the two ends of the line, there is no flow of reactive power. Okay, just 1 minute. I'm coming. Hmm. The series voltage, sorry, the series voltage that is being added is actually a voltage is added at certain angle. Unless you add the voltage at some angle, that means there should be some angle difference. Otherwise, what will happen? The transfer of power will not take place. It is a voltage is being added in series. So there, this phase shifter, it is implementing some phase shift. So because of this shift, phase shift, a power is being flowing. A power is flowing from this end to this end, or from this end to this end. Now the series voltage, it is also injecting some power. So since it is injecting some power, it has also to implement some phase angle difference. Otherwise it cannot actually push power into the circuit. That's why is that phase shift is needed here. Okay, because this series voltage injection, a voltage is being added, but obviously some power, since a voltage is being added in series, it will affect the power transfer. So which power it will affect? It is affecting the flow of power from this path. And for flowing power, for pushing power from this path, a phase angle difference has to be incorporated in the between the two phases, two voltages between which the power will flow. That is being done here. Okay, but between these two ends, one and two, there will not be any reactive power flow. If you see that these voltages are equal, means the reactive power here and here, they are same. Okay, in between there may be some reactive power flow from this circuit to this circuit, or from this circuit to this circuit, not from this one to this one. All right. Okay, any other question? Okay, now let me show you that there was another sheet. Just 1 minute. Let me open that one. Okay, now can you see this? Now this is the report sheet submitted by one of your seniors. Okay, and this is now because now last year and this year no experiments are being done. New experiment could be done in the laboratory. Now we have to depend upon this type of reports only. Okay, so this is the report along with the results I shall show. So this is drawn all right thing. Then these are the equipments that are used. Okay, and let me come here. Now here for angle measurement V1 to V2 is connected to reference terminal and V1 is connected to the input terminal. For measurement of delta 1 3, V3 is connected to reference and V1 is as the input, And for the measurement of delta 3 2, 3 is connected at the input and V2 is connected at the reference. So delta 1 2 means delta 1 2 directly, delta 1 2, and whether it is leading or lagging. That indication is given in the phase angle meter itself. Okay, that is an indicator. A light is there. A light when the lead glows, then indicates that the input is leading. When the lag glows, it indicates the input is lagging. Okay, so delta 1 2 V2 is the reference. V1 is measured. Delta 1 3 V1 is measured with respect to V3. Delta 3 2 3 is measured. V3 is measured with respect to V2. Okay. Now, what are the results obtained for the first round? Now, obviously, the power here is in the laboratory scale only, very small amount of power. In actual transmission line, obviously, the power will be much of higher, larger magnitude. Okay. So, you see that in the run one, the purpose was to transmit power, transfer power from N2 to N1. Okay, 2 to 1. So, 1 should lag. Delta 1 2 is lagging by 22 degree. So 1 is lagging 2 by 22 degree. Okay, D1 is lagging by 22 degree. And what are the power? P1 is 25.3 and P2 is 19.2. So from power from N2, 19.2 watt is the power coming out, but power ultimately reached at N1 is much larger. It is 25.2. How? Because of that series injection transformer. That means with the series injection transformer path, another power is being added. How much is that power? That is P5. Okay, that is P5, 8.2, but P4 was 9.6. That means this path 9.6 watt was being delivered by this primary end of the winding of the transformer to secondary winding. So 9.6 was measured here. Out of this 9.6, perhaps it was 8.2 or something. How much was that? 8 point 8.2. 8.2 reached here. 8.2 reached here. It measured 8.2 means 8.2 reached here. How it measured? Actually, in the wattmeter, current was this current and voltage was this voltage. Across 2 3. So wattmeter naturally it will give how much power is actually received by at the output of the transformer. One, what was the question? 9.6 minus 8.2. 1.4 is the loss. Okay, in the transformer. Okay, 1.4 is the loss in the transformer. Now, therefore, you see the P was received from this end, P4 was received by the secondary of the transformer through the series voltage injection. Now, P2 plus P5 should be equal to P3. Because we are measuring, there may be some inaccuracy, but let us see whether it is happening. P2 is 19.2 and P5 is 8.2. So it is 27.4. 27.4 is the power that should be equal to P3. It came 27.2. Okay, there are maybe some measurement error. So it is showing 27.2. But truly speaking, what should have happened? P5 plus P2 should have been equal to P3. It is 27.2. So P3 is the power received at this point. P3 this is the power received here 27.2, and this is the line. So through this line power will flow, a loss will be there, and some power will be measured here. P1, how much? Let us see how much is P1. P1 is 25.2. That means 27.2 minus 25.2. That means 2 watt is the loss in the transmission line. Okay. So you see that in the run one, power is being transferred from phase shifter N2 to N1 by means of this phase shifter. This voltage is leading this voltage. That means the indication is that power is flowing from this one into this one, this end to this end, but received power is more than the power delivered here. How? Because of the series voltage injection. Means through the series injection path, another power was pushed by this series injection transformer to the transmission line. In fax devices also, UPFs, exactly the same things happen. Okay, exactly the same things happen, but that happens to those power electronic components through a separate path. There is a voltage source, there is a separate path through which power actually flows. So here we are not using those fax devices or other things. Simply by using transformer, we are actually trying to implement, we want to demonstrate how the fax devices, basically the UPFC, works. Okay, so this is how you are controlling the power flow from this end to this end. Now, by changing the phase shift and voltage magnitude here again, you'll see that power is being transferred from this end to this end. Reversal of power flow through phase shifting and series injection. Let us see in the second run, that was implemented in the second run. In the second run, you see that delta 1 2, it is now leading. Delta 1 is leading delta 2 by 23.2 degree. Okay, 23.2 degree. What is P1? 20.8. That means power received at the power supply end is 20.8. Now you see that power is flowing from 1 to 3. Before, previously it was flowing from 3 to 1. So P3 was greater than P1. Now power is flowing from 1 to 3. So P to P1 is greater than P3. What is this difference is the loss, 20.8 minus 18.4. This is the loss. Okay, loss is this much. So then P3, then this is the power received from the series injection source 6.8. So 18.4 plus 6.8 means 24, 25.2 watt. 25.2 watt is the power received here. At you say that P5 plus P3. And what is the power here? P2, it is 25.6. It is close. There is always some inaccuracy is there, and that's why it is doing 25.6. Okay. So in this case, you see that power delivered is 20.8, power received at N2 is much larger. It is 25.6. Why it is bigger? Why it is larger? Because there is another power received from the series injection source, and that is 6.8, and 6.8 watt added up with 18.4. This is the total power, and that is received at N2. Okay, and here delta 1 is leading V1 is leading V2. That's why delta 1 2 is now leading. Okay. So this shows you how using this phase shifter and series injection source you are actually controlling the power flow. Let us see how much was the voltage. uh, let us see. No, that actually it is very difficult to calculate how much injection you have to adjust, because say we have not actually measured the, or it is difficult to control the parameter of the equipments. What parameters you are having? You have a transformer, okay, and you have those injection sources. It is very difficult to obtain all the parameters values and develop a mathematical model and calculate how much voltage at what angle is has to be adjusted, so that you can calculate and implement directly. That was not possible. What was done? We have actually adjusted the voltage, obtained the condition. Say voltage at the two ends are 50-50 always. B3 is the voltage obtained here at the end of the transmission line, and B4, B5 as the series voltages. Okay, B4 and V5, these are the voltages. It is 50 and 29. Okay, this voltage, that means V5 is the added voltage here, V5 is the added voltage here. Okay, what was the angle? B32 is the angle. Now it is difficult to match all the angle here, because in that case you will require to measure all the parameters. That was not possible. That's why those things were not done. Okay, the delta 2 3, that means b5 was added at an angle, and delta 2 3 means between 2 and 3. This was the angle 65 16.5 degree with respect to v3 2. 3 was leading 2. Okay, this is the angle at which voltage was added in the first case. In the second case, 12.4 lagging, 3 was lagging, and 2. Okay, but if you want to actually calculate how much voltage at what angle has to be adjusted, it is very difficult to say, because we have to, at the measurement condition, okay, how much current is flowing, then how much voltage and at what angle will actually push this much of power. This thing calculation is possible, provided you can control everything. You can have the measurement of all the parameters, you have the control over all the voltages. If that can be done, that is possible here. Here another thing is that actually here the source, hmm, yeah, it is done, but problem is that in this case, thing is that actually we are simulating here. What we are simulating here, this source is taken from the laboratory. What if the power supply available in the laboratory from here? What is the power supply available? That means from the same source we have taken. Physically, what will happen? Physically, this will be the end of a generator. This will be the end of generator at a very distant location. Okay, that isolation, this impedance, creating impedance in between, that is not possible in the laboratory. That's why we don't have that much of control. This is on limitation in the laboratory environment. Could I explain? That means whenever we are performing this experiment, you see that it is very difficult to adjust the values in the laboratory environment, because of the fact that this is the source available from the same point, like this one, as if from the same point in the laboratory we are taking this power, this source, and also this source. We are taking the single phase input here, we are taking the three phase input, but basically they are the same source, same point. But physically in the power system, what will happen? Power system, maybe this is distance between these two ends is say hundreds of kilometer. Okay, there is impedance, there is much separation of through impedance. That impedance separation is not possible to create here. If we could implement two sources, one here and one here, then we could have a better control over the parameter. That's why controlling everything here is not possible. Okay, that was not possible. Whatever from every year we are performing this experiment. Okay, we have seen that this is very difficult to get. Why this is difficult to get? Because of the fact that you cannot set the environment, actual environment that you are obtaining in the practical transmission system, because obtaining that would require creation of sources at the two ends of the transmission line, and that was not possible for us. If we had a source separate here, and say this could have been the available power supply, in that case this should have been a separate generator. If should we had we implemented a separate synchronous generator here, then this could have been done. But in the power laboratory, this was not possible. Maybe if we do in the ground floor in the machine laboratory, there you have a power source, synchronous generator. There this type of arrangement could have been done, but because of some other limitation, you know that this experiment has to be done in the power laboratory, that arrangement is available in the machine laboratory, so that could not was not possible to do. Okay, but if we could do this, then we shall have a better control. We can say how much will be the phase shift requirement, how much will be the voltage magnitude requirement. Could I explain? Because, and along with that, you have to know the parameter of all the um, all the devices. That means the parameter of transmission line, parameter, those couldn't be measured, that is no problem. But a separate source actually is needed here. And we must know the parameter of this phase shifter, parameter of this variac. Then, then in this case, we have not tried to do all these things, because then it will be much bigger thing. Our aim was to show that this is the way how you can control the flow of power through a transmission line. You can implement the reversal of power flow. You can also transfer power from one circuit to another. That was the main focus. And doing this accurately by implementing separate source and measuring all the parameters would have been a much elaborate thing that was not possible to implement here. Okay. So this was done, and then the third run, you see that what was done in the third run, P5, though it is very small magnitude, because it was very difficult to bring this situation. P5 was made greater than P4. Had we made that arrangement, then you could actually vary this power through a wider range. Now, since all the sources are from the same point, bringing that difference becomes very difficult in this environment. That is the main you can say negative point of this experiment done in the laboratory. Okay, that's why you see that P4 is 3.4 watt only, and P4 is now 1.8. Now actually, as if from the transmission line to the series injection source, power is flowing. What we want to show here, what we want to simulate here, as if power is being transferred from one line to another. Here in this case, in the third run, as I have mentioned previously, we are simulating the transfer of power from this line to this line, as if this is another line. And this could have been done had we connected another reactor here, another power supply source here, then this could have been done. But we have avoided that because it will be the duplicate arrangement we have avoided. But previously it was the power was flowing in this direction, now it is flowing in this direction. Previously this was series injection, now as if the series injection, but as if we are implementing the transfer of power from this circuit to this circuit. Previously it was in the reverse direction, now in this direction the power is flowing. Okay, from 5 to 4. Okay, these are the three runs through which the operation of unified power flow controller and interline power flow controller both are implemented. Okay, now then they are now shown all these things, verified all these things that I have discussed also, that roughly they are equal, may not be exactly equal, because you are measuring, there are some inaccuracy of measurement. So roughly they have implemented all these things. So I shall be actually sending you all these things, no problem. The sheet is already with you, and this report that was prepared by some of your senior students, this can be made available to you also, so that you can read, you can think, and then if you have other questions, you can make me that questions, we can answer, no problem. Okay, now if you have some question, you can. Okay, yes, it's power balance, they have simply just shown. Okay, any question you are having? Ball. So how many of you have joined? And so who are absent? 21, na 20 perhaps have joined, na? Huh? Which one? Acha, 19, 21. Actually, the screen is changing. Um, this one. Okay, okay. Acha, acha. Then Obhimanyu Shoni. I am reading out who are present. Obhimanyu Kumar Shoni is present. Okhil Koilada is present. Then Aman Singh is present. Amritangshu Kumar present. Onish Kumar is present. Ankon Dey is also present. Avinash Kumar present. Harshit Mathur present. Kaushik Mahata also present. Kishan Kumar Singh is present. Kumari Amisha is present. Mrinmoy Barmon present. Then Prashant Giri is also present. Pooja Dotto is present. Rahul Agarwal present.
Present, sir.
Acha, then Rishabh Ranjan Das is also present, I think. Saurabh Sheet. Then Shakir Sheikh is present and Shreya Giri. So altogether, therefore, it will be 20. Somebody has joined very recently, maybe. Na? Okay, then if 20 are there, you are supposed to be 21. Na? So who is 23? Then 3 are absent. Who are these three? Three are absent. You know their names? Achha. So if these are, we obviously we can determine who are absent. Okay. So another thing is that, so next week, therefore, some other group, you are uh, 23 in this section. That means another 23 will be another subsection. All right. They have done. Okay. Okay. All right. All right. So okay. Okay. Then let me. No, I don't have the roll sheet actually. Okay, sir. I am reading out from here. Use this mark. Who is absent? Obhimanyu Kumar Soni, Okhil Koilada, Aman Singh, Amritangshu Kumar, Onish Agarwal, then Ankon De, Avinash Kumar, Harshit Mathur, Kaushik Mahata, Kishan Kumar Singh, Kumari Amisha, Mrinmoy Barman, Prashant Giri, Pooja Dotto, Rahul Agarwal, Rajesh Kumar, Rishabh Ranjan Das, Saurabh Sheet, Shakir Sheikh, Shreya Giri. So, Victor Mondal is trying to join now. What is the utility of joining now? I am taking in, but why? Victor Mondal, Victor Mondal, you have joined now, but why is so late? What is the purpose of joining now? Victor? So you are effectively absent, not present. So who are therefore absent besides Victor Mandal? Uh, uh, Harsh Kumar, Harshit Mathuri is present. Harsh Kumar is no Victor. Victor who joined just very recently after the end. So it is meaningless joining now. Okay, all right. Okay, then thank you. If you are having other questions, you can make me. And report. So if you have to report, you prepare the report as per the instruction sheet given. Instruction sheet is with you, and for generating the report, the results are to be needed. So what are the arrangement made? I shall discuss and send you through mail. Okay, I shall let you know through this mail. what type of report is necessary to be submitted or at all to be submitted, that I shall let you know later on. Okay, because same results, everybody submitting the same reports, there is some utility, but may not be very effective in that case. But still, what is the arrangement made, what is the decision made, I shall know from others and let you know. Okay. So Victor is saying that his laptop was not working. Here's some Harsh Kumar Upadhyay. Previously, he was. I saw
Yes,
him,
sir, I was
but
there. Actually, my net went off, the Wi-Fi connection, and then I switched it on. It took some time to re-establish.
okay. Okay, then you also are present. Okay, I shall be trying because actually the recording also I have forgot to make it on from the very beginning.
Yes, sir,
So
I came up to the point where the recording was started. After
hmm,
that 15 minutes, then I went off. So I have seen the initial
okay,
part.
you have seen. Okay, in that case, if you want, I shall be sending you the recording also. Those who want, they can actually again see it and try to understand. And regarding report submission, I shall let you know. Let me know from others what has to be submitted. Okay.
Oh, okay, sure, sir. Thank you so much.
Okay, and then just get data to be obviously the this is the data available. So let me know first what is the decision regarding the report submission, and then I shall let you know through mail also. Okay, all right. Okay, thank you. Any question from anybody else? Any question? Okay, if no questions are there, then obviously now we may stop recording also. Hmm. Okay, thank you then. All right,
Thank you, sir.
thank you.